ladies and gentlemen, I would like for you to draw, we're going to draw 4 sets of DV&A graphs. So we're going to have 12 little axes all told, I guess I should say. So it's going to be D versus T, V versus T, A versus T. You draw that 3 more times. Okay? So go ahead and write those out right now as I'm doing it. One more. And then I'm going to give you one of the 3 from what we just did, okay? And I want you to draw the rest. Oops, that's not what I wanted to do. So this is not a test. I'm not going to quiz you over this right now. I just want you to work on it with your partners, okay? So this should be all of the stories that we just told, but I want you to have this to be able to refer to it. So please talk to your table mates. I want you to fill in the missing graphs, and then also next to it, write down a story that makes sense to you. So if you and your group before were doing this and it was like, oh, that story didn't make any sense, but this makes more sense, write down what you've got. This is for you and your notes to study from, okay? So please talk if you want. Have a conversation, figure this out. Bless you. Think it through. These translations are a little bit challenging. Remember, as you're moving to the right, you're looking at the slope, right? The slope of a graph determines the values of the next one when you're moving to the right. I'll get you. Actually, there's one right here. If you don't want to talk to your teammates while you're doing it, once you've got them filled in, check. Make sure that they've got it. Make sure that you've got it. And then remember, once you've got your graph drawn, write yourself just a reminder. It doesn't have to be like a 5-paragraph story, but just remind yourself what each of these is a picture of, just so that when you go back and look at this week or next week or whatever, and you're trying to like, oh, what did we do? What was this? They'll be like, oh yeah, I was talking about when the person was walking through the park. I was talking about when I hit the, brakes to get to the stop sign, whatever. Yeah. So the process is we look at the slope here. The slope is constant and positive. So that means the values of this one need to be constant and positive. Perfect. Slope here is 0. So the value is 0. So slope is constant positive. Slope is constant negative. Positive negative. Yeah. Yep. That's the weird one, right? Yeah. So here the values are increasing and positive and the values are decreasing. So you need your slope to be increasing. Oh, your slope to be decreasing. That's what it looks like, a kind of stretched out S. This one here. So the values here are positive and decreasing. So the slope needs to be positive. Is that a time lapse? Yeah. Yeah. Uh-huh. Yep. And then this is was it started here? Yes. So yeah, if you do, then it's going to change this. Yes. Yeah. But this is the one that was actually on the cover. Yeah. Well, and technically. Okay. So that's the format. So this is that's
Wouldn't it start here?
Without even knowing secret calculus stuff.
Why did you do it like that?
It's fast and then it slows down and then
I know, it's like taking away from it. Calculus is everywhere. Should we go through these, you guys? Make sure we're good?
Yeah.
All right, let's go through them. All right. So, this first one, I'm going to zoom this in so I can actually see it a little bit better. So on the first one, the displacement versus time graph, it's just going constant and positive and constant and positive, right? Constant slope, positive values means that this is going to be constant positive values, right? Yes. Velocity is going to be constant and positive. So it's going to look something like, come on, friend, there we go. Something like this. Is that okay? Was that the enthusiastic, like, yes, I got it right thing? Okay, awesome. You can keep doing that. That's all good. So again, we're looking at slope to get there. Slope to values. Are you with me? Okay, that's what you just got to say to yourself every time. We're going to look at the slope here. What's the slope of this line?
0.
0. So that means the values here are going to be?
0.
Oh, that's exciting. And our description for this story is what? A walk through the park or whatever. But we know that it's definitely got to be at a constant speed, right? So far, so good? That first one was easy-ish. Let's try the next one. All right. So I didn't give you a D graph. That's kind of mean. Sorry. That's what happens. So just a couple of little notes here. Would I ever on a test give you this V versus T graph and make you make a D versus T graph? Yes. Maybe not. Maybe. I don't know. But things that I might do are, here's a V versus T graph. Which of these D versus T graphs would match? Okay. Or tell me the story, right? I definitely might do this though. Go from V to A. Like I will move this way. I'm cool with that. Because that's just look at the slope, graph the values. Going the other way, those of my friends that have some sort of calculus mentality might be like, ooh, I can do different things. Ooh, that's funny. So we don't want to, I'm not going to count things wrong if it's not quite perfect. Let's go from V to A first, because that's the easy way, right? Look at the slope. Tell me about the slope of this V graph. Constant and positive. It's constant. It's not increasing. If it was increasing, it goes, right? So it's constant slope, positive slope. So here we're going to have constant values, positive values. Constant positive values. Here it comes. Constant positive values. Okay? Going the backwards way is a little bit harder. Makes your brain kind of work a little bit harder here. So here, the values are increasing, right? The values are increasing in positive. That means the slope needs to be increasing in positive. Okay, it's like a parabola. And the story for that one was what? What was that story? Accelerating in your car, right? You're going faster and faster and faster. So you were at a stoplight and it turns green and there you go. All right. This next one. Whew, we're starting back here. The values here are what and what? Negative and constant. So that means the slope needs to be negative and constant. So the graph that you had on in the activity we did looked like this. The reason that I wouldn't count something wrong, or I probably wouldn't ask this question, is because it could look like this, but it could also look like this or this. You with me there? Does that make sense? We don't know which of those cases it is. So I'm just going to leave it as one. That one. Okay? Because we don't know from this what your final velocity is. That's the key. I have a constant, the values here are not constant. They are decreasing and positive, right? Decreasing positive values means decreasing positive slope. Decreasing positive slope. Decreasing positive slope. Last one. This was the funny one. What's my A graph going to look like for this one? Right? Because the slope for V starts out constant and positive, and then it changes to constant and negative. So my values need to be constant positive, constant negative. Going over to the D versus T, this is the funny one, right? So the values here are increasing and positive. So my slope needs to be increasing and positive. Whoop, and then I hit this spot. And now they're going to be decreasing, but still positive. We good? Yeah.
What was the story for the last one?
What was the story for the last one? Who told us this story?
Kaylee.
Oh, Kaylee did. Can you tell us one more time? It was a great story.
Like you're driving and then you go down and up the hill, so the velocity is going to increase when you go downhill and it's going to decrease when you go up the hill.
Does that kind of make sense? Yeah. Or like if you're on a roller coaster, right? If you're at the very top of the hill, you go down and then you go back up. Same deal. Same thing. Yep. Awesome. All right. We know that when we're going from a velocity to an acceleration or a distance to a velocity, you look at the slope. Not only do we know that we can like sketch it out, but we also can calculate it. We did it when we rolled that ball down the hallway. Do you remember? We actually did it. We found the velocity. We found how fast that ball was going. The funny thing is that you can actually work backwards too from a velocity versus time graph to figure out how far you've gone. So I want to do that right now. We're going to try that out. So I'm going to call this working backwards. You might want to just sketch this graph out on your paper. I'm going to do this as 3, 2. I'm going to actually draw another line here for 1 just to make our numbers easier. What are the units of velocity? are the units of velocity? Distance over time. And what's our distance measurement that we usually use? Meters or centimeters. Usually, like the base unit is going to be in meters. And the base unit for time is seconds. If I forget that, I can always think about my equation, V equals D over T, right? D is my distance, that's in meters. T is my time, it's going to be in seconds. So my units for velocity are going to be in meters per second. Okay? My time over here is just going to be in seconds. And this right here is my graph. So my question is that I am traveling at 3 meters per second for 5 seconds. If I'm traveling at 3 meters per second for 5 seconds, how far do I go? Where did you get that number? Where did that come from? It's not wrong.
3 times 5.
3 times 5, right? Just, it like intuitively makes sense to you. So he just said 15. I don't know. 3 times 5. I guess it's 3 times 5. I guess it's 15. I'm going to say, yeah, that's right, but I want to make sure you know why. Okay? So let's take a look at that. If I know my velocity and I know my time, I can solve this for D, right? D equals V times T. Is that okay so far? This is easy if the velocity is constant. It's less easy if the velocity isn't constant. But I want you to take a look over here because I was just really reading off of this graph. My velocity is 3. My time is 5. If you haven't drawn this graph on your paper, please do because you need to have this so you understand how this works. Okay? Take a look at this. I have a velocity of 3 for 5 seconds. Oh, come on, stinker. Come on. There we go. And I can find that 15 by taking 3 times 5. We're dusting off that old geometry skill of finding the what of that rectangle? The area of the rectangle, okay? So really what we're doing when we're going from a velocity versus time graph to a displacement versus time graph is that we are going to find the area between the graph and the axis. Okay. This is second semester of calculus right here. Okay. Finding the slopes is first semester, done. Finding the areas is second semester, done. Now you know all of calculus. Now, does it get a little more complicated? Yes, but that is it in a nutshell. Take a look at this graph here. Here, I'm gonna see if I can move this up a little bit so you can see that and the notes at the same time. Drink. Can you tell me if this has traveled, or excuse me, if it's moving, this is 2 meters per second, and this is a time of 5 seconds. How far have I traveled during these 5 seconds? Take a look up there. See if you can figure it out with your teammates. Have a little conversation. I start off with a velocity of 0, I end up with a velocity of 2. How far did I travel in those 5 seconds? What kind of a shape do I have in this one, you guys? A triangle. Do you know how to find the area of a triangle? Boom, 1/2 the base times the height. What's the base? What's the base of that triangle, guys? 5, right? So we'll do 1/2, 5 seconds. What's the height? 2 meters per second. Check out these units. This is going to be so pretty. Are you excited? Half. Well, let's do 5 times 2 first. That makes it easy. Divided by 2 is? Boom, it's 5. It's 5 what? The seconds are on the top and the seconds are on the bottom. Those go away. You've gone 5 meters. Isn't that cute? Easy peasy. Do you say lemon squeezy or mac and cheesy? My kids fight about it.
Never heard of that.
Mac and cheesy, easy peasy mac and cheesy? That's what the older one says. The younger one says lemon squeezy. So we get in a fight every time I ever say easy peasy. So I try not to say anymore. But I appreciate that you said it. I don't know. I keep trying to think of other things too. All right. Here you go. I want you to take a look at this one. Okay. My almost 3-year-old will be super excited about that. She'll be like, yes, I win. All right.
Then it'll create more problems.
Right. The older one will be like, well, you should ask a different class. That's probably what she'll say. All right. Take a look at this. It says, shown below are 6 velocity versus time graphs. Some of them should look familiar because I just pulled them off of this. Okay. For toy robots that are traveling along a straight hallway. Okay. All graphs have the same time and velocity scales. It says, rank the magnitude of the displacement during the interval. Go. Go, go, go. Do this, please. What? That is your homework. Yeah. How are we doing? Are you ready to talk to your table mates? Are you totally confused? Are you done and ready to discuss with me? Talk to your table mates if you haven't done so already. Figure it out. Have a conversation with your team. What's that?
So like, you know how this one flips and then you just swap it 5 seconds.
Where did you see it?
Yeah, I know what it is.
So we have to change velocity.
See, I wouldn't. That's okay. No, it's okay. I'm introducing new stuff to you, right? I know, right? That's how we're doing it. Otherwise, I was just like myself, looking to tell you go, and you let people in. It's been a while, right? So yeah, let's do it. You're right.
Oh, yeah.
So then, so for number one, or A, it's just so how far it's down so that. And then it's over.
You can do it however you want. Like I thought it was easier to do each of them just because then I had a number like but it doesn't say, so you can make it whatever you want. You can make it like 12.
Oh,
I wouldn't, but you could. How are we doing over here, guys? So it's negative. So it depends on what you're using as your scale. So if you want each thing to be 2, which is what I was doing before, then you would do -2 times 5. Right? So it can be whatever you want to do. It can be 12 if you want.
Then C is the negative.
Yeah.
But yeah. D, so it should be okay. It'd be like 3.5 over 5.
D is today.
17.
Right. Yeah. Woo!
And then it'd be 1, 2 over.
All right, ladies and gentlemen, the bell's going to ring in just a moment. Hey, there it is. The green sheet that I just gave to you is homework, okay? Make sure that you pay attention to the labels on the graphs. One of them is a velocity versus time graph. One is a position versus time graph. Read it carefully. We'll talk about it tomorrow. Have a great Monday.